The future of Erlang LS. There is a chapter in the official Erlang documentation which is called the retire myth. It starts with a typo and it lists a bunch of facts which were true at some point, but which are not really valid any longer. Our goal today is to ideally enter, put a new entry in that page and finally dispel the myth that Erlang tooling is suboptimal. So I'm Roberto. I'm a software engineer at Klarna. I'm the author and one of the core maintainers of Erlang LS, the Erlang language server. And today, as Eric said, I'm here together with the George or Andreas from WhatsApp. We're going to talk about Erlang LS, the editor-agnostic language server providing language features for the Erlang programming language. If you haven't heard about Erlang LS before, you're probably missing out. And what I suggest is that there is a video from last year. It's titled Boost Your Productivity with the Erlang language server. And I strongly suggest that you look at that. It gives a full introduction about what a language server is and how to use it. Today, we will give a status update on the project on Erlang LS, and we will focus on two specific areas which are currently under heavy development. So let's take a step back. Erlang LS was firstly presented in September 2020, like 8 months ago. And already at that time, Erlang LS provided quite a rich set of features, including code completion, go-to definition, signature suggestions, inline diagnostics in your editor, inline documentation, ability to find references, and so on. And all these features were available by definition across all supported editors. So since Erlang LS is an editor-agnostic solution, you as a Emacs user or Vim user or Visual Studio Code user and so on, you get these features for free available out of the box. So the question for today is what happened since then? What actually changed in terms of Erlang LS? Well, the short version is a lot. We went from version 4 to version 15. We had tons of features, bug fixes, performance improvements. We added things like support for like detection for unused includes and macros that allows you to detect portions of that code in your code bases. We added renaming capabilities for functions and variables and so on. We give you ability of highlighting symbols. So now if you're hovering a variable in your Erlang module, all the other variables with the same name within the same function clause will be highlighted. So it's easier to keep track of what is going on in the code. We added support for snippets so that you don't have to manually type a try catch any longer. We have suggested type specifications coming directly from Dialyzer and TypEr. We have contextual code completions, meaning that, for example, if you are including a library using an include lib attribute and you start typing a path, maybe you want to include the new logger from OTP, Erlang LS can detect what kind of header file you want to include, so you don't have to remember in which application the header file, the application the header file belongs to. And we also added support for a debugger, which is quite amazing. And that's what Andreas will talk about later. But I don't want to bother you with all the features that have been added. We keep a quite accurate changelog. So you can go on GitHub on the Erlang LS page and you can see all the releases and you can see all the details. What I want to focus today is what really changed in this past 8 months. And the answer is that Erlang LS has been growing dramatically in popularity, but most important in contributions. So that screenshot on the right was taken last week, I think, and it's already outdated. Today we have 36 contributors to the code base, and the project essentially moved from a personal hobby project to a community project, which I'm really proud of. One thing that, one consequence of adding feature after feature to a product is not just that hopefully the product gains in popularity and contribution, but also that it gains in something else, which is called complexity. So one thing is, how do we actually cope with that with Erlang LS? How do we manage to include more and more features without having Erlang LS bloating with dependencies or exploding in complexity? Sure, we try to make our code as modular as possible. We try to use OTP patterns and behavior as much as we can. And we invest a lot in documentation, which makes it easier to contribute. But in the end, this only solves part of the underlying problem. The core principle that we try to follow in Erlang LS development is to not try to reinvent the wheels. So if there are tools and libraries that solve a problem, we try to leverage them as much as possible. Today, we are going to cover one of these tools specifically, which has a bit of an overlap when it comes to Erlang LS. And this tool is called Reaper3. It's essentially the de facto standard when it comes to build tools in Erlang, even if it's not the only one. This overlap, and it's quite evident when you look at a typical configuration file for Erlang LS. So this is what a typical config file would look like. You put this in the root of your project, and you can already notice that there are kind of two sections in this file. The one at the bottom, the one in white, it essentially is a list of preferences for how to customize the user experience of an Erlang LS user. Like, you want to use the language server, so you may want to enable or disable certain features. Maybe you feel a code length is too intrusive, you want to remove it. So all is good. But the top part, the one in red, it's quite annoying for a user, right? You have to inform Erlang LS of a bunch of facts about your code, your workspace. You have to tell where dependencies are, where includes are, and you're using custom macros, and you kind of you have to tell Erlang LS about this. What is most annoying for the user, I believe, is that this information is already expressed somewhere else. And if, for example, you're using Reaper3 as your build tool, this information is in fact available in your Reaper config. So wouldn't it be nice if Erlang LS could actually read that configuration? And instead of requiring extra configuration, well, it turns out it's not as simple as it is. Like, you cannot simply read the configuration, because a build tool such as Reaper3 does a lot of work on top of that. You expand path, you have a well-known data structure and so on. And that's where the overlap comes. Also, Reaper3 is not the only tool which is used. We have, believe it or not, companies that use other build tools. They could use Erlang MK or a custom build tool. So how can we solve this? How can we allow users to enjoy Erlang LS while not having to rewrite a configuration for their projects? Luckily, someone already thought about this and invented what is called the build server protocol. This is an effort that comes from the Scala community. So in the same way, a language server protocol allows the communication between a text editor and a language server, so that you can implement a language server in an editor-agnostic way. The build server protocol does the same between a language server and a build server. So it allows to talk to various build tools following a set of rules. So what we did was to create a plugin for Reaper3, which adds support for the build server protocol, in Reaper3. So imagine that now, when you start this plugin, you essentially have a server, a process. Imagine like a gen server, which holds the Reaper3 state in its own state, and you can query using the protocol. So let's look at how things work today. Today, the IDE, whenever you initialize a new workspace, it will spin up a language server instance, and it will start sending messages to this language server. So for example, an initialize message. As of today, the language server consults the config that we saw. So it tries to get the path and dependencies. It reinvents the wheel. So it does a lot of the work that Reaper3 already does. And after all of this, it will come back with a message saying, okay. How things change with the build server protocol is something like this. Whenever you initialize a workspace, so the editor talks to the language server using a discovery mechanism, which is part of the protocol specification, will figure out which build tool we are using, in this case, say Rebirth 3. It will spin up the build tool, so the build server. It will trivially execute the Rebirth 3 BSP, and then it will start querying all the information that the build tool already has. For example, give me the list of dependencies or path, so that it doesn't have to reinvent the wheels. All this complicated part of the code which already exists is delegated to the build tool. You get back the responses, and the responses are forwarded to the IDE. If you think well, this is a quite powerful mechanism because it allows us to do a lot of fancy things. For example, when it comes to formatting the code, well, one option that we have is that we start including formatters within the language server. So bloating the language server with all the possible formatters that now we have in our in the Erlang community. What we can do instead is that we can delegate and forward this request to the build tool, for example, using the Rebirth 3 format plugin, so that the build server can then take care of formatting, return a list of edits to the language server that then can be added to the IDE. So if you remember this huge configuration file, what happens really is that all the part that you have on the top in red essentially disappear, and is replaced by a single flag which tells to the language server that you want support for the build server protocol. And this may not be needed in the future. Right now, the build server protocol support is still considered experimental. So like, don't try this at home. You can feel free to play with this, but things will probably break as of now. This is still under heavy development, but that's at least the direction we are taking. And I don't want to take more time. There are a bunch of links. I will share the slides around Erlang LS. There is links to source code, documentation, and so on. And I will leave the stage to Andreas, that can instead tell us everything about the debugger that is now available in Erlang LS.
Thanks, Roberto. Let me just share my presentation. And here we go. So hi, I'm Andreas. I work at WhatsApp, and I'm going to tell you a little bit how we integrated the OTP debugger into the language server. But let's first talk a little bit about motivation, why we actually would want to do something like this. And first of all, we have already a graphic debugger that comes with OTP, but using that is really inconvenient, mostly because of two reasons. First of all, it takes a lot of steps to actually get to the point where we can debug our code. So we start our debug application from an Erlang shell. Then we have to navigate the menu to interpret some module. We have to, again, find some dialog to add line breaks or some breakpoints. We need to know the line number, did we manually enter there. And then we can trigger the code that we want to debug over the shell again, and double click on the right process in the debugger window. It pops up a new window that contains the source code, where we then see like the bindings and can step and execute some code and so on. So it takes a lot of steps from, hey, I just want to debug these functions, to actually being able to see something and do that. And the other thing is that the user interface isn't really that great, not just because it takes so many steps, but also because, first of all, if you have really large variable bindings, they're essentially unreadable. You have like one source window for each process that is currently debugged. So you pop out a lot of different windows that you need to manage. And you don't see a function stack. So you only see like the process, but you don't really see the stack of them. And another motivation is that really we don't want to use another tool, right? So we want to have the debugger integrated in our editor and have everything in one place to minimize context switches. And needing to go to like a shell and open up a different application that has like different user philosophy and so on really takes us out of our development flow. And thankfully, this is a common problem, and there is the Debug Adapter Protocol, or short DAP. So what is the DAP? The DAP is like a sibling or sister protocol to the language server protocol. So essentially, the LSP, the DAP, and in the future more protocols, they build a family of protocols that abstract from the editor and allow you to integrate the different services. In this case, it's a debugger. And like the LS, it's editor-agnostic, and it allows you to integrate debugger-like tools. And what I mean is that, of course, it's primarily thought for integrating a step debugger, but the protocol itself is actually super generic, and you can imagine also implementing, for example, tracing or something like this, if you implement the callbacks correctly. It's supported by a wide range of editors, so I will demonstrate how debugger works in VS Code, because that's just what I use. But if you have Emacs or Vim, there are definitely DAP support available for that as well. And implementing it at once, like for the LSP, automatically provides functionality for all the other editors as well. So just short for history. Yeah, and when we end up, wait a second. I think I jumped over something. Yeah, so historically, this started as a hackathon project on Roberto, and Alan, and they produced a proof of concept with basic DAP implementation. And in the spring this year, we polished this up and added a lot of missing features. And where we end up with is a mostly feature complete debugger. And to show you how that works, like, or where we are, I will just show a little demo. Okay, can you all see the demo? Or some browser?
We still see the line.
Okay, let me try to do this again. Now?
Oh, the same.
Do you see a tree now? Do you see
yeah, we see a tree now. Only your desktop with a tree.
Only the tree, or do you also see
only
a video?
Tree. No, only the tree.
Okay.
The demo.
Yeah.
We tried this 5 minutes ago. It worked.
Okay, now?
Now we see cowboy.
Awesome. So to show you, so I showed a little demo, and essentially what we're going to do is we're going to debug a REST handler of cowboy example, REST baseband from the example library. So what I did is just took the code and put it in a standard rebar project. So I added the rebar config and so on. So if you want now to start debugging this thing, the first thing that we need is to have a launch configuration. And if you're using VS Code, you can just press in the fresh project, create launch.json file, choose the Erlang or DB debugger, and you will get like some reasonable defaults. This showcases essentially all the different config options that you can set currently. And you will get an option rebar shell. And if you press the play button, you will start a rebar shell, which will start up cowboy and the handler. And here we are. So another thing that you need to debug is a breakpoint. And you can easily set this by just clicking left to line number in your editor. Now we have a breakpoint. And finally, we need to trigger the code. So we go to a terminal and curl some stuff there. And surely enough, we see that the editor breaks at the breakpoint that we have set. You have the standard control elements for step debugger. So you can step into a function And now you actually see the function frame, and you can click around and see the different variable bindings. You can click back. You can step next, and finally you can press continue, and you see that, hey, we got some response back. The one thing I want to show you is that with the DAP integration, you can structurally navigate variable bindings. So the request here is a large map, and we want to inspect the user agent of the header. We can just click around and see that, hey, this thing is indeed curl. And we have the same interface across all surfaces where we interact with variables. So if you hover, we can unfold the stuff. If you go to debug console, which is essentially a REPL for the debug process, we can do exactly the same thing. We have a watch list. So if you have a large amount of bindings in your current scope, you can just say enter a variable name, in this case paste ID. It's unbound currently because it hasn't been set yet, but if we step over, we will see that this will going to be updated. All right. We can not only inspect variables, but we can also manipulate the values of those variables. So I think this paste ID is really unreadable, and I want to set it as something that I can remember better. So I can go to the debug console and just say paste ID equals something that I can remember, for example, debug. And with this, the current scope is updated, the watch list also is updated. And if I now press continue and check in the terminal, I see that the location is debug, and I can remember this much better. All right, so this is everything to like normal breakpoints. But the DAP actually describes a whole variety of breakpoints that are useful in different situations. And I'm going to just start going through them. So the first thing that you can do is that you can set a conditional breakpoint. So if you right click in VS Code, and then you get a little dialog, and you can say, hey, I can enter some expression here, and the breakpoint will only break if this thing evaluates to true. So if I now curl the same request on there, it will just not break. But I can, of course, change the echo here to test, and hopefully, and then the breakpoint will hit because the condition is fulfilled. So the other type of breakpoint that I want to show you is that it's something called a lock point, and that's essentially you can, at those points they don't break, but they evaluate an expression and print the result into the debug console. And so if I would be interested in just a paste ID, I can enter the expression there, curl a bunch of requests. You see that it does not break, but if I look at the debug console, I have those log messages. And the final thing, or the final type of breakpoint that I want to show you is something called a hit point. And the hit point does not break every time it is hit, but it only every nth time. So if you know, oh, I want to debug this every third time or so, then you can say like 3 here. And if we now curl requests, then it will stop at the first time. But if I curl 2 more, they don't stop, and the third one stops again, and I can do that again and again and again. All right, so that's everything I want to show you about the debugger today. So thanks for listening, and I'm open for questions, or we are open for questions.
Thank you very much, Andreas. Thank you very much, Roberto. This is awesome work, and I think the whole community owes you a lot for what you've done over the past, it's less than a year, right? So just give a big hand. I mean, turn on your speakers in the audience, and let's give a hand. That was a nice sound test. Thank you all. Let's go into the Q&A. So let's see what we have in Whova and how you have voted for the different questions. So I'm just going to refresh and see, and I'm going to ask you to unmute and ask the question. So on top we have a question from Håkan Nilsson. So Håkan, would you like to unmute and ask your question, please? I'm going to give you one more chance, Håkan, and otherwise I will ask it for you. Okay, so the question from Håkan is, what changes to Erlang OTP would enable better, interesting features in Erlang language server?
Well, I think what they did with OTP 24 is already a pretty big step. Having the column numbers gave the ability to show exactly where like the error is. And they also had support for the documentation. I think it's an ongoing discussion. So I think what I'm really happy is that the Erlang OTP team is very well aware of Erlang LS and all these tools. So whenever they are designing things, they have these tools in mind. So it's been quite obvious in the latest release, and we'll see what happens. It's already visible that when you expose certain tools to much bigger user base, you see the limits of these tools. I'm thinking, for example, TypEr, which is this little tool which was created to suggest type specifications, but of course has its own limitations. And I don't think it was ever used widely. But now that people see suggested type specifications coming from TypEr and Dialyzer directly in the editor, they start complaining to Erlang LS, say like, why is this displaying like this? Why so slow? Why is it can I do this instead? And then we forward those requests to the OTP team, and we talk to them.
I think that's a great insight, and that brings back memories of hearing Robert and Mike and Joe talking about how they worked closely with customers initially with Erlang and OTP to get those quick feedback loops, what is working, what is not working, what to fix, getting feedback from real users. I mean, that's really, really super important. So that's a very positive side effect, actually. That's really cool. So next question, Max Nordlund. Max, would you like to unmute and ask your question?
Yeah, I did not know what this talk was going to be about, but I asked what about the debug protocol and then what about the build server protocol?
Yeah, they're in a pretty decent state. I would say the debugger adapter protocol is in a way more advanced state, and Andreas maybe can expand on that.
But DAP, we mostly, so we implemented like most features. There are like there's some polishing left doing, so it crashes sometimes, but it's minor issues, I would say.
Then I had two follow-up questions. One, how to enable it. I know that in VS Code it has to be enabled in the package.json something so that VS Code actually understands that there's some debug adapter. And also, how can I use this when debugging tests? Like, I want to use this when I run EUnit, or I want to use this when I run the command test.
That's an excellent question. Maybe I can take this. So if you use VS Code, it's just there, right? In the latest release, it's bam. The really interesting question is, how do you do with tests? Because you have, and I think that's like a broader question, because we have implicit timeouts everywhere in Erlang. And like just stopping a process like a gen server for a couple of seconds usually crashes that thing. And I mean, ultimately, step debugging is something very intrusive into the system, and there's no good solution to it. So maybe adding tracing as a second DAP alternative in the future gives you something good. For tests, so what you can do is you can add multiple time traps for common test, at least, that elevates, like gets rid of the time traps or timeouts or crashes and so on.
And to reply to the first part of the question, I think the BSP protocol, it's way behind. So we have a vision, a mission. We know what we want to do, but the implementation is still not completely there. So if you just enable BSP, you expect things to break. And we are also considering that we have a few, like the current implementation of Erlang LS, when it comes to dependency management or even compilation of individual modules. We will probably keep that around, but maybe we will make it compatible to the BSP so that we have a single way to interact with BSP. And then either the local implementation or a Rebirth 3 implementation or any other build tool can essentially implement and interface using the same mechanism.
Okay, cool. Let's move on. Julius Andrikonis has a question here. Julius, would you like to ask it? Unmute.
Yeah, sure. Thank you. Thank you for your presentation. And my question would be about the performance of the Erlang LS server. Well, after your perfect last year's talk, well, I had an idea to implement an Erlang server support for another IDE. It's called Atom IDE. It's not perfect. My implementation is not perfect by any way. I'm not a good JavaScript or plugins programmer. So that kind of could be the problem. But I noticed that starting the server, it took quite a bit of CPU, quite a bit of RAM, and well, having several projects running, several different projects, Erlang projects, they all started their own servers, and that may be not ideal, but how can improve the performance of Erlang LS server?
So there are a few tasks which are especially CPU or memory heavy, and most of them are related to dialyzer and type specifications. So we already have been looking at those and try to see what we can do to kind of simplify things. A lot is going on when you start a new workspace. There is some initial indexing that takes place, and that's the most expensive part. So usually, I mean, in our organization, we use it with 1.5 million lines of code. So it's not like a small project, and it kind of works. I also have a dialyzer enabled for this and type suggestions. It takes a while, like your CPU goes nuts for a while before it settles down, but we can try to optimize these things. And also there are a bunch of other things which have amazing contributors that I also see in this room. Hi, Håkan. Hi, who was there? Peter. And yeah, I mean, there is many. And some of the work that I've been doing has been in terms of performance. For example, Håkan is currently working with changing the way the data is passed between the editor and the language server. So right now, we only have the full text. In the latest release, the full text is passed to the server on every keystroke, which is surprisingly not a big problem for even decently big modules, but it starts to be a problem when you have modules which are thousands of lines of code. But now this has been shifted, so there is an option that you can configure so that you can only pass the diffs. So only the changes that you actually apply are passed to the server. So this kind of optimization, I mean, they will come. So the more people use this tool, I think the more they will emerge. And what we suggest is always to report them and explain what your current project is, what's the structure, what's the size, and what kind of problems you have, and we can help troubleshooting.